Hello friends, this is about the subset sum problem, which is an example of the backtracking. You should first understand what is backtracking before understanding what is subset sum problem. Backtracking is the principle of solving a given problem by choosing one component. If it forms a solution, then we choose that component. And if it doesn't form a solution, we backtrack. We choose another component and check whether that will form a solution or not. You will understand it better through this example why subset sum problem is using the backtracking principle. And in backtracking, we have to construct a state space tree. It is called as a state space tree. You can see, just look, don't see the problem. You can just see a tree construction which is done here. Hence, all backtracking problems mainly use this state space tree. And we have either a promising node or a non-promising node. What do you mean by a promising node? A promising node is such node which forms a solution or which helps us in getting the solution to the problem. And non-promising node is such a node which does not give us a solution to that problem, or by choosing that component we do not get the solution to the problem. And the time complexity of solving the subset sum problem is big O of sum into n, where we calculate the sum and we print all the subset that is present. Hence, we always choose the best case and tell it as sum into n. Here is a given problem. S is equal to 3, 5, 6, 7 and D is equal to 15. Now, let us see. You will understand it much better. These are all the individual values and totally you will have to get 15. By adding any combination of numbers, you will have to get the sum as 15. So, now we shall choose 0. Before starting the problem, you just take it as 0. And that is the root node. The first element that is present in the S set is 3. So, with 3, without 3. Both the cases you will have to take. With 3, add up 0 plus 3, it is 3. Without 3 means we are not choosing 3, hence it remains as 0 itself. Now, we shall expand this half, this half, this half, this half, okay? And now, we choose next is 5. With 5, without 5. With 5 means 3 plus 5 is 8. Without 5 means 3 plus nothing, so it remains as 3 itself. Next element is 6. So, 8 plus 6 with 6, without 6. 8 plus 6 is 14 and without 6 is 8. Next we have 7. So with 7, without 7. 14 plus 7 is 21. Without it is 14 only. 8 plus 7 is 15 and without it is 8 only. So at the end you should see. Now we don't have any other component to be added. You can just check out. Is any of the thing giving you the solution as 15? Yes. Here is a particular case where you are getting the solution as 15. So this is one of the solution. Here and all you are not getting the solution as 15. It's given in the problem. According to that you will have to take it. Here and all you are not getting 15. So only one solution is formed at this end. Now you just backtrack, go, and you see you will have to complete this path. Without 5 you had done it as 3. Now with 3 and 5 is over in this part. So now you choose 6. With 6, without 6. With 6 will give you 9. That is 3 plus 6. Without 6 will give you just 3 only. I have not expanded it with further with 7 and without 7. Obviously 9 plus 7 will be more than 15 and it will not give you a solution. And without that will still remain as 9 and that also doesn't give you a solution. Similar is the case with 3 also. You can just check it out in your mind. Here I have shown the various solutions. It's not coming. You can just calculate it in your mind and only then tell whether it forms a solution or no in the last step. This side we had just done without 3 and it was still remaining as 0. Now you choose the first value. 3 was over. Now we have 5. With 5, without 5. With 5 will give you 5. Without it will give you 0. Next, with 6, without 6. With 6 will give you 11. Without it will give you 5. Here with 6 will give you 0 plus 6 is 6, without 6 gives you 0. Next, last component that has to be added is 7. None of the cases here you get it as 15 as the solution, so there is no need for writing down that particular step. So in the entire tree you're getting the solution 15 in only one place, that is with 3, with 5, without 6 and with 7. This is the path that is present. That is the solution I have written. Choose only the cases which has with 3, 5 and 7. You add all that, you get the sum as 15. So this is one of the solution to the subset sum problem. Thanks guys for watching the video, and you can also have more than one solution sometimes.